Okay, let's look at a question on linear momentum. And the question says, a body of mass 4.0 kilogram moving with a velocity of 2.5 meters per second collides with a stationary body of mass 0.2 kilogram. If the two bodies stick together after collision, calculate the magnitude of the velocity with which they move. In this question, we have two bodies given. For body A is a moving object, while body B is a stationary object that is not moving. Now, let's try and interpret the question. Let's say we have a body, let's say a stone, and the mass of this object A, the mass is 4.0 kilogram, moving with a velocity of 2.5 meter per second. Let's call it object A, moving with a velocity of 2.5, that is V, initial velocity, that is U, equals 2.5 meter per second, collides with a stationary object. This object B, let's say the second stone B, object B is the stationary object that is not moving, but we know the mass. The mass of this object B, that's let's call it MB, is 0.2. Let's call this one MA. But the velocity of object B, stone B, is 0. Why? That is UB is equals to 0, because it is a stationary object, not moving. So when these two collides, when these two objects collides, when the two objects collide, then they stick together. The question says the two objects stick together. The two objects stick together. That is stone A and stone B. They stick together and then move with a common velocity. They move with a common velocity. So the question now is, calculate the magnitude of the velocity with which they move. The two objects moves with a common velocity after sticking together. And we know that law of conservation of linear momentum says that momentum before collision equals momentum after collision. That is, momentum before collision will be equals to momentum after collision. That's what law of conservation of linear momentum says. Now, the momentum before collision will be momentum of body A plus that of body B. Before collision, momentum before collision will equals to what? Momentum of body A, that is MA UA plus MB UB. That's the momentum before collision. Then momentum after collision. After collision will be equals to, now the two bodies stick together. to form a body. So their masses will be added together. That's Ma plus Mb. But since the two stick together, they move with a common velocity represented using capital V. So our equation now, will be MAUA, that is collision before sorry, I beg your pardon, linear momentum before collision plus MB UB is equals to MA plus MB, then with the common velocity. So the common velocity with which the two bodies move after sticking, that is after collision, is what we are asked to find. So our MA, this MA here is the momentum. MA is mass of body A, that is 4.0 times initial velocity of body A, 2.5, plus mass of body B. Mass of body B, that's 0.2 times velocity of body B is 0, since it is a stationary object, not moving. So is equals to mass of body A is 4.0 plus mass of body B is 0.2. So multiply by the velocity. Okay. Now 4.0 times 2.5, that gives us 10. That gives us 10 plus 0.2 times 0, that gives you 0. So is equals to, then multiply this, 4.0, add the masses together, 4.0 plus 0.2, that is 0, sorry. So 4.2 plus 4.0 plus 0.2, that will give you 4.2 V. So we are asked to find this. That would be 10 equals 4.2 V. So divide both sides by 4.2 now to get your answer. So this cancel this. So you have V is equals to, when you use your calculator to divide that, 10 divided by 4.2, and that gives you 2.38 meter per second. And that is the velocity with which the two bodies move after collision. And that is referred to as the common velocity. And that's our final answer. Thank you for listening.